Hey there. Ever wondered if AI is just a fancy Google search, or if there's actually a digital brain working behind the scenes? Well, you're in the right place. In this series, we're going on a journey together. First, we'll unlock the secret language of AI, the tokens. Then, we're going under the hood to see the massive GPU engines that power it all. And finally, I'm going to show you how you can take all that power and run it privately on your own computer. It's a lot, but don't worry, I've got you. Let's dive in.
All right, so let's get right into it. First things first, we gotta tackle the big one. How is an AI actually different from something like Google? I mean, you ask both a question, you get an answer, right? Well, yeah, but how they get there? Totally different worlds.
And look, it's a totally fair comparison. It feels the same, doesn't it? You type, you get a result. But what's happening behind the screen, it's a whole different story. It's kind of like comparing a super efficient librarian to a creative artist.
So think about it like this. Google is a collector. It's basically the world's most amazing librarian. Its job is to find information that already exists on the internet and just point you to it. It's not creating anything new. But a generative AI? That's a creator. It's more like a chef. It has all these ingredients, all the data it's been trained on, and when you ask for something, it doesn't just find a recipe. No, it actually cooks up something brand new just for you based on all the patterns it's learned.
Okay, so if the AI isn't just doing a fancy search, then what is it doing? How does it even understand our questions in the first place, let alone write something completely new? Well, it all comes down to a kind of secret language that these AIs speak.
And that secret language is built out of something called tokens. Honestly, the best way to picture tokens is to think of them like Lego bricks. One little brick isn't much, right? But when you start snapping them together, you can build literally anything. That's exactly what AI does with language.
So what is a token, exactly? Well, it's the basic building block, the smallest piece of language the AI can chew on. But here's where it gets kind of weird. A token isn't always a whole word. Nope, it could be just a piece of a word, or even just punctuation.
Let me give you an example. Let's take the word categorical. For us, that's just one word, pretty straightforward.
But for an AI, it sees it completely differently. It might break it down into chunks, like cat, gory, and cow. Each of those is a separate token. And this whole process of breaking our words down into these little Lego bricks, that's called tokenization. It's the very first step to translating our language into computer language.
And it gets super specific. A tiny word like AI, yeah, that's probably one token. But a word like amazing could get split into amaze and ing, 2 tokens. Even an exclamation mark is its own token, which, by the way, is a fun little fact. It's why when you use services like ChatGPT, you're literally paying for punctuation. To the AI, it's just another piece that has to think about.
Okay, so this is the most important part. Once everything is tokenized, each of those unique tokens gets its own special number, like an ID. So our word categorical isn't a word anymore. To the computer, it's just a string of numbers. And that is the real magic trick. This is how we turn something as messy and beautiful as human language into pure math that a machine can actually work with.
So our question is now a bunch of numbers. Cool. But how does the AI go from a list of numbers back to, a real sentence that makes sense? How does it build its reply? Well, it all comes down to a single, incredibly powerful idea. Next token prediction. And it's pretty much exactly what it sounds like. This one simple concept is the engine behind everything the AI does, from writing an email to generating computer code. It's wild. So here's how the loop works. The AI looks at all the number tokens you've given it so far. Then it digs into its massive brain and calculates the mathematical odds for every single possible token that could come next. It picks the one with the highest score, adds it to the end of the sentence, and this is the key. It starts the whole loop all over again, but now with the new, longer sentence. It does this over and over and over, building its response one single token at a time. I know probability sounds a little mathy and abstract, so let's use a super simple example that will make this click for you instantly.
Imagine you type in twinkle, twinkle, little. The AI has seen that phrase like 1 billion times in its training. So when it calculates the odds for the next token, the word star is going to have a crazy high probability, right? Like 95%. Maybe light has a tiny chance and car has almost 0. So what does the AI do? It just picks the most obvious one, star, and adds it to the sentence.
And this is such a crucial point to understand. The AI doesn't know what a star is. It has no idea about astronomy or nursery rhymes. It just knows that based on all the human text it's ever read, the word star is the most statistically likely thing to come next. This is also why AIs can sometimes just make stuff up. We call it hallucinating. It's not trying to lie to you, it's just giving you the answer that looks the most probable, mathematically, even if it's completely wrong in the real world.
Okay, this is great. We've got tokens, we've got probabilities, but where is all this stuff happening? Where does the AI keep its giant brain? And where does it keep track of the conversation we're having right now? The best way to think about it is like a library versus a workbench. The AI's entire knowledge base, every token it knows, all the connections between them, that all lives in a huge, permanent file. That's the library. It's massive, and it's where the deep knowledge is stored. But the conversation you're having right now, all those tokens are loaded into the super fast memory on the GPU, called VRAM. That's the workbench. It's where the active work happens, but it's small and temporary.
And this totally explains something you've probably experienced. You know when you're having a really long chat with an AI, and after a while it starts to forget what you talked about at the beginning? That's because its workbench, its VRAM, is full. It literally ran out of short-term memory. And when you start a brand new chat, the workbench gets wiped clean for the new project.
Which brings us to, like, the million-dollar question that everyone, even the top researchers, is still debating. If the AI is just predicting the next most likely piece of a mathematical puzzle, is it actually thinking? Does it understand what we're saying? Or is it just the most incredible parrot the world has ever seen? Just an expert mimic that's gotten so good we can't tell the difference. It's a pretty deep thought, right? But for now, I'll just leave you with that to chew on.
Have you ever just stopped and wondered what an AI is actually doing when it generates an answer? You know, it can feel a lot like magic, but it's not. It's this incredible step-by-step process. And today, we're going to pull back the curtain and show you exactly how it works. So, to make this real, we're going to walk through a specific example together. Let's say we ask an AI to create a super detailed interview guide for an AI architect. But here's the thing. We're not just going to look at the finished guide. Oh no, we're going to see how the AI builds it, literally from scratch, word by word.
All right, first things first, we have got to bust a huge myth right now. When you ask an AI for something, it is not doing a search. It's not digging through some massive digital filing cabinet for a document called AI Architect Interview Guide. What it's actually doing is, well, it's way cooler than that.
Okay, so think about it like this. A search engine, that's your librarian. You ask for a book on a topic, it goes to the shelf and finds it for you. It finds existing stuff. But a generative AI, that's more like an author sitting down with a blank page. It creates something entirely new. It isn't finding information, it's building it.
So you're probably asking, if it's not looking through files, where does the knowledge come from? And the answer is something called weights. Just imagine this massive, complex web of connections, kind of like a brain's neurons. And all the model's knowledge, its entire understanding of words, ideas, and how they relate, is compressed into the strength of those connections as pure mathematical patterns.
And just to give you an idea of the scale we're talking about, even a really simple neural network, one designed just to recognize handwritten numbers, can have around 13,000 of these weights. Now picture each one of those as a tiny little knob or a dial. The AI is constantly tweaking thousands of these dials all at once to perfectly craft its answer. Okay, but wait, if there are no folders, no tags, how on earth does the AI know that a concept like scalability or a really specific technique like RAG, that's Retrieval Augmented Generation by the way, is related to our AI architect prompt? The magic here, and it's really cool, is in something called a vector space.
I want you to picture a giant, multi-dimensional map, but instead of cities and countries, it's a map of ideas. On this map, things that are conceptually similar are mathematically close to each other. So king and queen, they'd be right next door. But king and canoe, they'd be on opposite sides of the map. The AI creates this incredible map for basically every concept it ever learns.
And this is where your prompt becomes so important. Your prompt is like a flashlight. When you type in AI architect, you're pointing a powerful beam of light onto one very specific spot on that giant map. And everything in that beam of light, all the nearby related ideas, they just instantly activate. So in that little glowing spot around AI architect, what do we find? Well, we find all its mathematical neighbors. You've got technical skills like scalability and MLOps. You've got frameworks like PyTorch and those advanced concepts like RAG. They all light up because on this map, they're all clustered together.
And what's not in that beam of light is just as important. All those concepts that are mathematically miles away, things like, I don't know, sous vide or cast iron skillet, they're left completely in the dark. The AI's focus is laser sharp, right on that one relevant cluster. See? No tags needed. It's all just math.
Okay, so the AI has identified the right neighborhood of ideas. It's got its flashlight pointed at the AI architect part of the map. But how does it go from a cloud of related concepts to an actual, coherent interview guide? The answer is that it builds it one single word at a time. Or, to be more precise, one token at a time.
This whole process is called next token prediction, and it's crucial to understand this. The AI is not planning out the whole document. It has no grand plan. It just looks at what it has just written and calculates the most probable next word to add. It's exactly like building with Lego bricks. You just add the next brick that seems most likely to fit.
Let's actually watch this in action. The prompt ends with create interview. So what's the most probable next word? Questions, of course. Okay, now the AI has a new starting point. Interview questions for an AI architect. From there, it knows that a numbered list is a very probable structure, so it predicts one system design. And now, with that as the context, the next most likely phrase is, how would you design? And on it goes, building the answer one probable piece at a time.
But hold on. This brick-by-brick thing sounds like it could get messy, right? I mean, what stops it from just repeating itself or rambling on forever? How does it actually create a clean, coherent 10-question list instead of just a big jumble of words?
Well, this is where two very clever systems come into play, working together. First, you have the context window. Think of this as the AI short-term memory. It helps the AI remember, hey, I just wrote question 1, so let's not do that again. Then you have the attention mechanism. This is like its internal compass, always pointing back to the original prompt to make sure it doesn't get lost.
And that attention mechanism is absolutely critical, especially for longer answers. It's what maintains the vibe of the whole request. It's the reason that 500 words into the document, the AI is still laser-focused on AI architect and hasn't slowly drifted off course and started writing questions for, say, a Java developer. Okay, let's pull all of these threads together for what is, I think, the most fascinating insight of all. We've seen how the AI uses its map of ideas and predicts the next word to build something that looks like an expert wrote it. But here's the big question. Does the AI actually know what an AI architect is?
And the answer, really, is no. This is the big takeaway. The AI doesn't know or understand things the way we do. It's never been an AI architect. What it is an incredibly skilled navigator of a massive probability map. It synthesizes what looks like expertise by simply charting the most probable path through that giant interconnected web of concepts.
So that's what we'll leave you with, a final thought to chew on. If a machine can synthesize world-class expertise without a single shred of genuine understanding, what does that really mean for the future of knowledge itself? Something to think about.
Hey everyone, and welcome. So today, we're going to do something a little different. We're going on an exclusive tour, kind of like getting a special access pass to peek behind the curtain. We're heading straight into the AI engine room to see what really makes these amazing tools work. Okay, let's get into it.
You've totally been there, right? You ask an AI a question, and poof, this brilliant answer just appears. But it's not actually magic. It's this incredibly complex dance happening between hardware and software. So the real question is, what does that dance actually look like? Well, that's exactly what we're here to figure out.
All right, so here's the plan for our tour. First, we'll step inside the engine itself to see the hardware. Then we'll meet the team, a lone professor versus a whole army. After that, we'll check out the AI's personal workbench, follow a tiny piece of data on its journey, see how an AI crams for a test, and finally, watch how it earns its PhD. It's going to be fun.
Okay, first stop, the engine room. We're talking about the real physical stuff here, the metal and silicon that give AI all of its incredible horsepower. Let's go meet the crew inside. Now, you might think that the main brain of a computer, the CPU, is doing all the heavy lifting. But when it comes to AI, it has a totally different partner that's, well, it's way, way bigger.
Let's think about it like this. The CPU is like a genius professor. It can solve really complicated problems, for sure, but it has to do them one by one by one. The GPU, on the other hand, it's like a massive army of math students.
Each student is just doing one simple calculation, but there are thousands of them doing it all at the exact same time. And that's why the GPU is the true powerhouse for AI.
And this superpower, this ability to do thousands of things at once, is called parallel processing. And honestly, this is the whole secret. The math behind AI is basically billions of simple calculations, which is the perfect job for our army. This parallelism is what takes AI training time from like months down to just a few days or even hours. It's a game changer.
And if we look even closer inside these GPUs, it gets even more specialized. You have CUDA cores. Think of them as the general soldiers in our army. But then, modern NVIDIA GPUs have something called tensor cores. These are like the elite special forces, designed for one single mission, to speed up a specific kind of math that is the absolute foundation of how AI works.
So, we've got our army of processors ready to go. But where do they do all this work? Well, an army needs a battlefield, right? And an AI needs a workbench. This is where memory comes into play.
You know, a big AI model is a massive file. We're talking 40 gigabytes, sometimes even more. It can't just hang out on a slow hard drive. So when the AI is actually thinking and talking to you, where does that enormous model actually live?
The answer is VRAM, which stands for video RAM. This is the GPU's own personal, super-fast memory. You can think of it as the AI's workbench or its fuel tank. And here's the most important part. The entire model has to fit inside that VRAM to run. If it's too big, the engine just stalls. No exceptions. This is a huge bottleneck in the industry, and it's why high-end AI gets so expensive.
And that's exactly why you see these professional GPUs with just massive amounts of VRAM. A card like the NVIDIA RTX A6000 can come with a whopping 48 gigabytes of it. That's not for playing games. It's to create a big enough workbench to handle today's giant AI models.
Okay, so we have our super powerful engine and a huge workbench. But how does your prompt, the information you type in, actually move through this whole system? To get that, we need to follow one single piece of data as it travels down the AI's assembly line.
First things first, AIs don't really read words like we do. Instead, they chop our sentences into these smaller, more manageable pieces called tokens. So a word like categorical, for example, might become 3 tokens: Kate, Gory, and Cal. Then each token gets turned into a number, because deep down the AI only speaks one language, and that language is math. So when you send your prompt, those number tokens enter the assembly line at the input layer. Then they travel through what are called the hidden layers, and there can be dozens of these. This is where all the thinking really happens. In each layer, the token's information gets processed and transformed, helping the AI understand things like context and nuance. Finally, it hits the output layer, whose job is to predict the single best token to say next.
So how does that information actually flow from one layer to the next? Well, the YouTube channel 3Blue1Brown puts it perfectly. It's like a chain reaction. The pattern of neurons that light up in one layer directly determines which neurons are going to light up in the very next layer.
And what's controlling that chain reaction? The AI's knowledge. This knowledge is stored as millions or even billions of numbers called weights. You can think of each weight as a tiny little knob that controls how much influence one neuron has on another. All of these weights, together, are basically the sum of everything the AI has ever learned.
So we know the AI's knowledge is stored in all those weights. But how does it get that knowledge to begin with? This brings us to the 2 major phases of an AI's life. Its time in the study hall and its time taking a live test.
So, the study phase is officially called training. This is where the AI learns everything it knows about the world. And the live test phase? That's called inference. That's what's happening every time you ask it a question, and it uses its knowledge to give you an answer.
During that study phase, the training, the model basically gets to read a huge part of the internet. By going through trillions of words, it slowly, carefully adjusts those millions of little weight knobs, gradually learning all the patterns and relationships in human language. This is the really hard work. It's super slow and takes massive amounts of computer power.
But once the training is done, all those weights get locked in. Now during inference, the live test, the AI is just using that knowledge it already has. When you ask it a question, it just does the math really fast to calculate the most likely next token for its reply. And that's why it feels almost instant. All the slow, hard learning is already finished.
Okay, so a fully trained model is kind of like a university graduate. It has a lot of general knowledge. But what if we need a specialist, like an expert lawyer or a master coder? Well, that's where the final step of its education comes in.
This step is called fine-tuning. And I love this quote from Google Cloud that explains it perfectly. It's like teaching a smart student the specific skills they need for a particular job. You're not starting from scratch. You're just giving it some focused, expert-level training for one specific task.
So a general model might be able to write a pretty good essay, but a fine-tuned model can write a legal brief that follows a very specific legal format. Or a general model understands coding, but a fine-tuned one can expertly write code in a particular language. It's the process that transforms a smart generalist into a true specialist.
And that pretty much brings our tour to a close. From the army of processors and the GPU to the amazing journey of a single token, we've really seen what brings an AI to life. It all kind of leads to one big question for the future. As these AI brains get more and more complex, how are the physical engine rooms we build for them going to have to change and evolve too? Something to think about.
Hey everyone. So we all use AI pretty much every day, right? For everything from getting a little help with homework to brainstorming some really creative ideas. But have you ever actually stopped to think about where that AI lives? It's a way bigger question than you might think, and trust me, the answer is super important for keeping your stuff private and just using AI the right way.
No, really, think about it for a second. When you type a question into one of those chat windows, where does it go? And where is that answer coming from? Is it in some giant data center like hundreds of miles away? Or could it be running right here on your own computer? The answer to that question? It changes literally everything. Okay, so let's get into it. Basically, AI has two totally different homes, and each one has its own set of rules. You can kind of think of them as two completely different neighborhoods. You've got the super powerful public cloud, and then you have your own private computer. So on one side, you have the cloud. This is like a huge, bustling city of supercomputers where things like ChatGPT live. It's awesome because you get instant access to the most powerful models from basically any device. The only thing is, your data has to travel over the internet to get there. Then on the other side, you've got your private fortress, your own computer. When an AI runs here, your data never, ever leaves your machine. It is completely private, it works even when you're offline, and you're the one in total control. So yeah, it's the ultimate trade-off, public power versus your own personal privacy. Now, running your own private AI fortress sounds pretty amazing, right? And for privacy, it absolutely is. But there's always a but, isn't there? There's a bit of a catch when it comes to performance.
See, your local fortress is only as strong as your computer's hardware. These AI models need a really powerful graphics card, a GPU. If you don't have one, the AI can be kind of slow. But more importantly, it might have a really short memory. We call this a small context window. It's kind of like a person's short-term memory. If it's too small, the AI can literally forget what you were talking about just a few minutes ago. The cloud, with all its giant server farms, just doesn't have that problem.
But hey, don't let that discourage you. Getting started with local AI is actually way easier than it sounds. You can think of tools like Llama and LM Studio as the keys to your own private fortress. They make it super simple to download and run these powerful AI models right on your personal computer, so you can experiment with total, complete privacy. Okay, so we've talked about where AI lives. Now let's talk a little bit about how it thinks. Because whether it's in the cloud or right there on your laptop, AI can be a bit of a glitchy genius. It can be incredibly smart one second, and then the next, it can be confidently 100% wrong. So let's talk about this term you see here, AI hallucination. It's honestly the perfect way to describe it when an AI just makes stuff up. You have to remember, AI isn't like a library or a database. It's really just a probability engine that's always trying to predict the next most likely word. And sometimes, that process leads it to create information that sounds totally legit, but is actually completely made up. And this is just a perfect example. The YouTuber Network Chuck asked a local AI model who he was, and it confidently told him he was Rick Grimes, the main character from The Walking Dead. It's hilarious, right? But it's also a really good reminder that these systems are not sources of truth. They're powerful tools for sure, but they are also flawed. So all of this brings me to what I think is the single most important piece of advice I can give you for using this tech. You have to treat AI like a brilliant partner who is also, sometimes, a little bit unreliable. The golden rule is super simple. Trust it, but always, always verify what it tells you. Hallucinations are one thing, but there's a deeper and honestly more serious issue that we all need to be aware of. I like to call it the internet's echo. It's all about how these AI models don't just learn facts from the data they're trained on. They also learn and inherit our very human biases.
It really is that simple. These AIs are trained on like trillions of words from the internet, from books, articles, websites, forums, you name it. They learn from this huge ocean of human knowledge and conversation. But that ocean also has all of our prejudices, our stereotypes, and our blind spots. And the AI, it learns all of that too.
And look, this isn't a small thing. It's a huge ethical challenge. Big organizations like UNESCO are looking at this really closely because if we're not careful, AI can end up just repeating or even amplifying the same unfair biases that we see in the real world. You can think of the AI as a mirror, and it's reflecting back our collective digital self, warts and all.
Okay, I know all of this might sound a little bit heavy, but the point here isn't to scare you away from using AI. Not at all. It's to empower you so you can use it smartly and safely. So let's wrap this up with a simple, practical guide for how to do just that.
So here are 4 easy steps to using AI the smart way. First, always know where your data is going. If it's sensitive stuff, local AI is probably your safest bet. Second, fact-check everything. Treat every single answer it gives you like it's just a first draft. Third, question its perspective. Always remember where it learned from, and ask yourself what viewpoints might be missing from its answer. And finally, think of it more like a creative partner for brainstorming, not an encyclopedia of facts.
At the end of the day, the power of AI isn't just in the technology itself, but in how we, as thoughtful people, choose to use it. Now that you know its secrets, where it lives, how it can be a glitchy genius, and how it echoes us, the real question is, how will you use it? Thanks for listening.